Hello, I'm María Ángeles Burgos. I'm joined by Charles Ford and Wayne Messam. Together, we created Nightfall Harpooner, an underwater action game.
We all met starting a game jam, and the main idea of this video is just to break down the audio system of Nightfall Harpooner.
Yep, Nightfall Harpooner uses Wwise to create interactive audio as part of its audio system. The reason we used Wwise is to ensure that sound wasn't just reactive, but actively reinforces player feedback and environmental storytelling. This approach reflects how we think about programming audio systems as a core design element that enhances interactivity and player immersion. Okay, so the first thing that we're going to do is integrate Wwise into our Unreal project. The process is pretty standard. We go to Wwise, install our version. The important part is that 2023.1.5 is the version that we're using for the project. So that means that every other computer needs to have 2023.1.5. And then we go into Unreal Engine, Action Project. And then it's going to say integrate Wwise project. So we basically just integrated Wwise into our Unreal project. From there, we went into our Unreal Engine folder that holds our U project. We right clicked and then we generated Visual Studio project files. And then after that finished loading for us, we went into the solution file and then we build our project from the solution. We did run into a few issues where there was bugs relating to the Wwise integration process. So all we did to fix it was that we cleaned the solution and then we rebuilt the solution. And then after that, everything worked just fine. So here in Unreal, basically to confirm the generation took place, we went to our Wwise browser and then we generated sound banks, and then we reconciled the selected sound banks. If you don't see this in your own project, then all we did was went to Window, and then Wwise browser is right here. Right after we reconciled our U assets, it created this folder called Wwise Audio, and then it placed all of our assets here. And because this is a collaborative project, we opted to use Microsoft Azure DevOps in order to act as version control for our project. So we just cloned the project, and essentially I'm using Git fork and Marion here used GitHub desktop.
In order to assign sound effects to our buttons in the UI, we created a new variable inside our WBP button base. In this case, we called this variable select event, and we connected it to the AK event inside this post event function, which will be triggered every time that we click on the button. After we created the button base, we just populated the main menu with them. And as you can see here on the Details tab, we can use the variable we created to assign a different UI-wise event for each specific button.
Okay, so our music hierarchy, it starts with a post event, which starts our switch container, which is going to default to the explore state. We created different states like combat, death, and as well as one for the divers port. For our explore tracks while you're in the ocean, we used a vertical layering approach for the music using an RTPC and adding layers depending on how close the player was to the enemy, to try and communicate the threat level to the player, even if they couldn't see them.
All right, so how we implemented the audio, or the music, I should say, for the ocean level is we first triggered the ocean level music to play on the begin play of the level blueprint. What happens first is we post an event and it sets the state for the music that we're in to the underwater level. because we wanted to take an interactive approach with the enemies in this action game, we made a system where the player diver has a few sphere colliders. In these sphere colliders, we can detect enemies that are approaching us, and if a enemy was to collide with this first collider that is 5,000 units out from the center, being the player, then what would happen is we would cast that enemy and add it to our far enemies like array for BP enemy base, and then we will tell it to set its in proximity variable to true, and then when it leaves, essentially we would take that same enemy and remove it from our array and also set in proximity to false. This is important for any movement that might happen when the player is not moving, but we'll get into that in a bit. Next, what happens is that whenever the player is going to be moving using IA move, basically if the player goes up, down, left, right, wherever they're turning, they're basically going to be checking for the proximity of the closest enemy. Based on the closest enemy's values, we're going to change the music to be more upbeat and add certain elements to the music. So here in this function, we're going to see if the far enemy's array is empty or not. If it is empty, then we're just going to set the exploration music to 5,000 and keep it there. And if the far enemy's array is not empty, that means there's an enemy in our first collider. What we're gonna do here then is we're gonna check if we're in combat. We would be in combat if there is an enemy that penetrates the second sphere collider. The reasoning being is because we want to check and see if we are in combat to know whether we're still playing the exploration music or the combat music. So the thing about this setup is that we wanted to avoid using the event tick when it comes to notifying us whether an enemy is close to us or not. So we ran into an issue where if the player is not moving at all, but an enemy gets closer to us, we wouldn't be able to detect that enemy through the music. So how we rectified that is by going from the enemy side, and every enemy has a AI function that basically informs us when they are traveling or roaming anywhere. They can basically do a proximity check when they land to wherever they end up. The idea is that in this behavior tree, after they finish patrolling and they're roaming, we do a proximity scan in order to do a proximity check. If the player has identified this enemy as a far enemy, it already has its in proximity check set to true. If the enemy already is within our far enemies array, its in proximity boolean is already going to be set to true. So that way, when we're doing our proximity check on the enemy, we can get the distance it is from our player and compare it in our player diver's movement system. That way, we're able to take the music and make it interactive without using the event tick.
Okay, so this is the explore music. When you're just kind of swimming around, we tried to keep it nice and airy, kind of give that feeling of the open expanse of the ocean and everything. And then as you go closer to an enemy, we bring in some kind of percussion that starts to kind of communicate to the player that, you know, there's a threat. And then this happens when the enemy still hasn't necessarily spotted you, but as you move closer, your state will change into combat, which brings the more aggressive music. And then when you move out of that, it'll go back to the Explorer. Or if you dispatch the enemy, then it would change too.
And as you can see, the blue bar signifies my O2 levels. As soon as that goes down, you'll be able to see our switch, our music switch. And then that's our character death music.
As for the underwater scenes ambience, we opted for a layer design, so depending on the player's depth in the water, we'll hear more or less of these layers. To do this, we created an RTPC called Underwater Depth, where we assigned the same depth values we predefined in Unreal. Then for each one of these layers, we connected the RTPC to the voice volume, and for some of these layers, we also used the voice low pass filter.
Okay, so the player diver has a simple setup. Basically, we are going to look at how the player is going to be setting these RTPC values. So one thing that we wanted to make sure that we did was that we wanted to stay as far away from the tick in regards to audio as possible. So what we opted on doing is we went to our movement system, and basically whenever the player is triggering the event IA move, which is basically the input for moving the character or swimming, essentially what they're going to do is we're going to tell the player to move in whatever direction on the X or Y value. We're going to set the player set the movement past that. Basically what this Boolean is doing is we're checking if we're swimming or not. So then it's going to go into swim movement, and then it's going to go from swim movement to set movement values. Set movement values is essentially going to set our variables up for direction and swim speed. But it's also going to get the actor's location, and on the Z value, it's going to match it up with the RTPC value that we have within Wwise for underwater depth. So that is how we are setting up our RTPCs for the swimming and underwater depth.
So we are here in the underwater level, and as you can see, each ambience layer voice volume is changing as the player goes up and down. For the character swimming sound effects, we created different sounds for each direction and for when the player is idling. Each of these are random containers with variations of the same sound, and for each of them, we created separate play events. In Unreal, we implemented this using anim notifies, so we created one for swimming, which defines the direction of the player movement in the water, and for each one of these directions, we are posting the corresponding Wwise event. Once we did this, we went to each of the movement animations and we added the anim notifies in sync. And for each one of these, we also selected the direction the player is moving so that it triggers the correct sound.
So when we're looking at the sound effects for swimming, all of the different animation sequences are acting within this blend space to trigger the sound at the right moment. So as I'm swimming, you can hear the idle sound effects and the random containers from the forward, side, and backwards. This is while sprinting. mountain. And that's how swimming is. So here in the underwater level, I see an enemy in front of me. I'm locking onto it, and we have our sound effect for the harpoon gun as well. Connects to it. It's not a complete mechanic yet, but as you can see, the sound is always going to attach towards the enemy.
Our character in the underwater level is a diver. Therefore, we design an O2 breathing sound that varies depending on the O2 tank level. For that, we created two states, one for the normal breathing and one for the critical breathing. Then we also created a switch container for these two states, for which we had designed two different sounds. These sounds are being triggered by an event called Player O2 Breathing Switch that at the same time is being triggered by this event that is called Play Enter Underwater Level. This is an event that is being triggered at the beginning of the level, which involves different actions. One of them is to pause the breathing switch event. How did we implement this in Unreal? First of all, we have this Player Enter Underwater Level event right at the beginning when we start the Begin Play event. So this breathing sound will start as soon as the level starts. When the player begins overlapping with the water, we will start this function called Start Swimming. Here, this event will also trigger this swim mode, which is basically a sequence that defines the swimming movement of the character. The last thing that this does is to deplete the O2.
So for the O2 to deplete, we opted for using a timer instead of the event tick to save for performance. The first thing that's going to happen when the player spawns into the map, you have an actor component attached to them called AC player stats. This is a custom actor component that we used to initialize their stats before the game starts. So the first thing that's going to happen here on the begin play is that we're going to initialize our gear, and all we're doing here is we're getting our owner, we're casting to the BP player diver, setting it as a variable for later reference, and then we are triggering this function called initialize O2. It's going to trigger a calculation that we made in order to get the appropriate depletion rate based on the equipment that the player character has. So what's happening in this pure function is we're getting another active component within the player diver called BPC equipment, which basically has all the stats from the currently equipped gear that the player has, and then all of those gear sets have their own stats within them. We basically use those variables to perform some calculations to get our depletion rate for the O2, because it's more advantageous to stay underwater and collect your gear for the round that you're playing on. So for now, we're using a debug depletion rate, but for the purposes of the video. But essentially, we would just have a default depletion rate of 100, and then deduct from there based on a timer. And that timer is being triggered all the way here when we are entering swim mode. So toggle O2 depletion is basically going to call a function within the AC player stats to create a timer that's going to call this event diminish O2. What diminish O2 does is that it takes the O2 depletion rate that we just found and decreases our O2. The depletion amount is calculated based on that O2 depletion rate. So when we're decreasing O2, we have some calculations, basically taking our current oxygen levels and trying to see if we like maxed out on it every step of the way. And then if we did, we're just going to like if we did deplete it, then we're just going to keep it at 0, but if we, or 0 here, and then if we didn't, we're just going to keep deducting it for however long it's happening. So in toggle O2 depletion, what's happening here is that every 0.01 seconds, it's going to call this event called diminish O2. After all the deductions are done, every 0.01 second of the timer happening, it's going to go back to the player driver and adjust the O2. So if we go back to the event graph for the player driver, event adjust O2, it's going to take the percentage amount of our O2 tank to tell if we are in critical means or not. So it's basically going to check if we're under 20%. And then if we are, we're going to set the state to critical. And if we're not, we're going to have the state set to normal. So if this is what affects the switch for the breathing sound effects. And that's how we adjust from our O2 states. So here in the ocean level, as you can see, the O2 is depleting down. The O2 is the blue bar. And the green bar is just my stamina. So soon it's going to reach 20%, and then the O2 breathing sound effects is going to hit a critical state. So the transition was a little obvious there. And then of course, the dying. Okay, and as for replenishing the O2, we have this O2 refill station. So within this station, what's going on is we have a simple begin overlap. This overlap is going to cast to the player. As soon as the player cast succeeds, it's going to grab the AC player stats component, and it's going to toggle the O2 depletion timer and turn it off. And then for the O2 replenishing timer, it's going to actually turn it on.
So here we have the AC player stats. Here's where we are setting the timer for replenishing the O2, if the replenishing condition is true. And right here, we are posting the event for the O2 fill sound. In the BP player diver, we are checking if the O2 level is below 20%. If it's below 20%, then we are setting the O2 state to critical. And as soon as this level goes beyond 20%, we are setting the state to normal. We can see here, as we are swimming through the level, that the oxygen is decreasing, so we need to refill it. And as soon as we begin overlapping with the O2 refill station, the oxygen level starts to increase. We could hear, and also we could see in Wwise Profiler, that the play O2 fill event has been triggered.
In the divers port, we use more of a horizontal layering approach, switching states, switching tracks, depending on if the player was exploring the port or trading with the item shop or fishmonger.
All right, so we're here in the Ocean Divers port. How we implemented the music is we first activated it through the level blueprint. If we go here, we see a post event on begin play telling us to play _ enter ocean divers port as an event. What's going on with every NPC, as far as transitioning the music, is we basically every NPC basically has this AC dialogue actor component. What this actor component does is it actually displays all of the different dialogue options for responses to communicate to the player. When the player chooses to begin talking, a widget will pop up asking them for their response. The way we have our music set up, we have the music set up based on which shop you are entering. If you are entering the fishmonger shop, then it's going to set the state for exploration states for the music to fish shop. If we're at the marine engineer shop, we're going to set the state for exploration states to item shop. And then the corresponding music will play for there.
So here's the ambient music for the general exploration of the divers port. Here's the music for the item shop. And this is the music for the fishmonger.
For the divers port ambience design, we used 2 layers. One is the station bed, which is a static ambience that is going to be present throughout the port. And then we have, on top of that, different ambiences for the different rooms that the player is going to go through. For each one of these rooms, we created multiple switches, and we assigned them to each sound effects in the switch container. So how do we trigger all these ambiences properly in our game? First, we created an unique event for when we enter the diver's port that contains multiple actions. For the ambiences, first we have a switch between our scenes called AX scene switch, and we are setting that to trigger the station bed. Second, we have the AX station switch that is going to switch between the different ambiences as the player enters each room. And how did we implement this in Unreal?
So in Unreal, what we have here is a map of our divers port. You can see here each of the different rooms have these box colliders around them. These are custom events or custom blueprints that we made to showcase the different ambience that specific layer is supposed to be featured in. So inside this blueprint, we have a simple begin and end overlap for the player for when they enter and leave this environment object. Then it's going to, if it's the player that's overlapping with these objects, then we're going to set the switch to the defined switch that is belonging to each of these environment objects. So be it the bathroom, the bedroom, cafe, aquarium, shop, or the entrance to the underwater level. And then when we exit, you might notice that there is not a singular environment object for the hallways. Because of the design of the map, what we opted on doing for this particular section is that when we exit any of these areas, save for example the bathroom, it's going to lead to the hallways. So that's exactly the switch that we're going to set when we end overlap, which is going to be the corridor switch. And here it is in action. So as you can see here, we have our player character in the entrance to the underwater level. You might notice that for the profiler, these two sounds make up the whole of the ambience bed for the station. The only thing that's going to be changing within the profiler is this dome water, which is the specific layer for whichever room that we're in. You'll also see that the audio buses, or aux buses I should say, for the reverbs are also here as well, but we'll cover them later on down the line. The main point is that when we are transitioning between each of these ambience rooms, you'll see that there's a change in the ambience bed, or not the ambience bed, but the specific layers for each location. So this is the aquarium. Back into the corridor. Next, we're going to try out the shop. Then back into the corridor. And we made it so that it was adjustable so that it doesn't just automatically have to go back to the corridor. Sometimes you might have situations like the cafe, or where we're inside, we could clearly hear the cafe ambience. And then when we walk into the bathroom, we hear the bathroom ambience. But if you noticed within the actual layout of the map, the bathroom ambience is within the cafe ambience. So leaving the cafe ambience will bring us right back out to the, or leaving the bathroom ambience leads us right back to the cafe ambience. And then last but not least, we also have our living quarters. Alright, so what we have here is the doors that are highly unique. We ran into quite a few issues actually with this door. At first, the way that we saw the doors, we thought that the most appropriate action to take was to make a sound effect for the doors opening, then the doors closing. They're not typical doors, they're more mechanical, and they are opening based on position. So if I walk up to it, as you saw, the bracers open and then the doors open, and then the doors stay open. And what we had planned was that we'll have a sound for the doors opening and then separate it from the sound from it closing, which is this. But in practicality, we thought about the triggering of the sound and how it would actually work. And after some trial and error, we discovered that the player has the ability to interrupt this sometimes. So like the door could be opening and then closing based on how the door is designed, right? So all of these need to be accounted for. So those two sounds didn't necessarily encompass the whole of the sound effect. So what we opted up doing was dissecting the sound even further and having a sound for the bracers themselves, which is what you see going in and out like right there. The door opening, and then a loop for the door opening, and then a closing door sound. So the door starts to close and then a loop for that close happens, and then those same bracers are locking into place. So let's look in Unreal how exactly that's set up for us. Okay, so for here we have BP door north south, and for door north south we actually have door open lock event that plays right out the gate if the player overlaps with the door. We're setting our user created boolean called opening ? On, and then we are triggering the timeline to activate the animation for the door. So within this timeline, it's set for 2 seconds. So that means with the door alpha, this is the progress bar on how far the door is from opening itself. The door itself opens in 1 second. However, you'll see that the timeline is set for 2 seconds because the first thing that happens is actually the braces. So here we have the braces alpha, which is the progress bar for the braces. It's basically going to go from 0 seconds to 1 second to fully open, unlock, or lock the braces into place. We also have this event here called on braces locked. This is that 1 minute mark that intersects between the two of them. This is a very important marking because the event that's going to be triggering the sound effect for whether we're closing and locking back up the braces, or if we are starting the sound effects for opening the doors, it's going to take place right here on this 1 second mark. So it might be hard to visualize here, but we're actually providing that functionality over here. So here you have the door alpha, the braces alpha, and then the on braces lock event. So how this timeline works is that update is happening every frame. It's going to do the actual functionality for setting the world location for the doors. Now that that's handled, as that animation is happening, the first thing that's going to happen is the braces alpha aspect of it, which is unlocking the braces. When the braces lock is activated and the door starts opening, we're going to check our boolean that we made to see if it's opening. On true, it's going to play door opens start, which has a few different commands in this singular event, but essentially it's going to start the door opening sound effect, and it's also going to play the looping opening sound effect that you'll be hearing for the door to continuously play until the door is fully opened or it's interrupted and going to close. If we're not opening, it's actually going to do this timeline but backwards. That means the doors are going to start closing all the way till they finish closing, and then once they finish closing, the event is going to happen right here. That's going to end the closing loop, and it's actually going to start the braces closing as well. And then either way, when that is finished, we're going to check one more time if we're opening the doors, because if we are, basically what we want to do is play the sound effect of the doors finishing their opening sequence, and we want to be able to stop the opening loop that's going on in the background as well. We'll cover that more when we get into Wwise, but this is just the functionality of how it's actually happening. And the last thing to cover is the actual closing process. So if the player ever leaves or interrupts the door closing in any way, shape, or form, wherever it is on the timeline, it's going to post this event. So it's going to start playing the closing loop, and then we're going to set our Boolean to false for if it's opening or not. Timeline, one last look again, we'll see that it's probably going to be around here in this area where the door is opening, or anywhere that's just not 0. And then it's going to go backwards because we are playing the reverse of wherever we're at. And then the same event will happen, and then everything I told you about the opening sequence, if it's false, is going to play out there. And that is how the doors are operating here. As you can see, we have the box collider for the player to interact with, and essentially the bracers themselves, and the door itself is a whole blueprint, so we're able to activate every aspect of it here. And now let's take a look at Wwise.
Okay, so in Wwise we try to design a structure that will allow the sound to match this door animation in Unreal. And for that, we broke down the sound in different parts. For example, the door opening sound is not just one sound, one event. We actually have a sound for when the door starts to open, a looped sound for the sliding part, one for the door reaching the end, and we have a sound for the lock that is represented by those braces that Wayne just showed us. For the door closing, we have just 2 sounds because in this case we decided to have just the looping sound and another sound for when the door finishes closing. How did we structure this in the events? Well, it's very similar to what Wayne just explained. We have one event for when the door starts opening. This event will play a sound for the start, and at the same time, an event containing the opening loop is going to be posted. Then, once the door finishes opening, we have an event that is called Play Door Opens End that will play the end sound, and at the same time is going to stop the opening loop that we are hearing. If instead we have the door closing because, for example, the player starts to go away from the door, then we have this event that is called Play Door Closes Loop that will start the closing loop sound, and at the same time is going to post the event that stops the opening loop. So this will help to get the exact sound that we want for when the door opening is interrupted because the player is going away and the door starts to close. And so on. We have different events to replicate all these door animations. And this is how it looks and sounds when you open the door, when you close the door, and when we interrupt the door movement. Let's say the door is opening, but we move away from the door. And that's how we performed the sound design so that it matches the door animation behavior.
Okay, so next we'll be going over how we implemented our character footsteps. And within Wwise, we created a switch container to tell whether we are running or walking. And then within these switch containers, essentially we divided up the different material types of the floors, and we placed random containers within each of them to provide some variation between the different footstep sounds. We linked all of these switch containers to our switches, so we have a switch for whether we're running or walking and all the different ground materials here. And then last but not least, we have our character jumping, landing, and footsteps events for when they're ready to be played in actuality. Here in Unreal, how we set it up is that we created a blend space similar to our swimming. So whether we're walking, running in any sort of direction, you should be able to hear it. And then similar to our swim locomotion, we have our AN walk for all of these animations. Essentially, it's working a little bit differently from the anim notify for swimming. But essentially, we're reading the ground material that the player has on the bottom of their feet by editing. If this is the level and we have our ground material set to this, for example, we could call this concrete. So for every single ground material that's in the level, or should we say asset, because we are using modular assets, we're able to create a socket within each of these assets and identify, put an identifier in a place of a socket and call it concrete to make sure that we have the most accurate ground material for Wwise to pick up. There are some exceptions. So for this piece in particular, we have these metal stairs here, and we created a bypass class called BP surface type override to override the surface type whenever we see fit. So if the player was to step anywhere within this box, instead they would see rusty metal. So let's go into that class real quick. It has one variable called ground material, and it has an enumerator for all the different ground materials. And essentially what we're doing is we're beginning the overlap, and then we are setting an override based on that ground material and sending it out to the player diver. So whenever the player diver is triggering the event to play a footstep sound, what we're doing is we're getting the floor material, which is going to the BP player diver, and it's going to check if we're overriding. If we are overriding, then we're going to follow this function, which is called override material switch. Override material switch is basically going to get our override ground material, which is being set by whichever ground material has been changed last, and we're going to switch on that ground material, and depending on which one it is, we're going to set the Wwise switch to that ground material, whether it is tile, rusty metal, concrete, or platinum. But that's specifically if we're overriding. If we're not overriding, then that means whatever the ground material is set on the static mesh, the modular static mesh, is the one that we want to use. So in this case, it would be concrete. So if in this example, override would be false, we would go to switch ground material. And then over here, we would get the mesh and create a line trace. For those of you that are more familiar with Unity, you would know this as like a ray trace. But we're creating a line trace, and then if we get a hit on something below us, we're going to read the socket of that static mesh, and if the static mesh of concrete exists, then we're going to set the switch to concrete. But if it fails, it's going to check the next statement to see if it's metal rust, and so on and so forth, until we finally get to the only other possible answer, which is tile. So yeah, that's how our footsteps are implemented into the game. So here is how our footsteps are sounding in the game. This is walking. As you can see in the profiler, it's triggering the appropriate footstep. And even though the static mesh for the floor is one material, this override object is going to count the stairs as metal. And back to concrete. This is running. This would be the platinum. And yeah, all of the rooms, all the ground floor materials are acting the same.
Besides the doors, we have a few other 3D objects, 3D emitters in our game. For example, we have some TVs, computers, we have a bar, an aquarium, and some pipes. For each one of these, we created a specific positioning configuration with similar attenuation curves for volume and low-pass filter based on distance. Something important that you can see here is that the maximum distance is a large value, and this is because in Unreal, the distance units are in centimeters. That's why we needed to put this large value here to make it match the Unreal distance units. For each one of these sounds, we created these events that you can see here, and now let's see how we implemented this in Unreal. We have two different ways of doing this. The first one, for example, for this computer component, we go to the event graph and right at the begin play event, we just post the Wwise event containing the computer sound. The other way to do this, let's consider this TV, is just to select the component and in the details view, we add an AK component to it. Then in the AK event section, we select the Play Station TV event. In our game, the player is a third-person character. In Unreal Engine, the default audio listener is set at the camera. But here, we didn't want that. We wanted to set the audio listener in the player character's head. To set this, we used our BP player base, and we added a function called setAudioListenerOverride, and we attached it to the scuba mask component. The scuba mask is a component that is attached to the character head. This way, we make sure that the listener is well positioned at the head level. Then we also changed this adjust looking function to make the camera rotation match the player rotation every time we move the mouse. Okay, and how does this work in the game? Let's see. So in this room, we have a 3D emitter in that TV playing some music. And then in this aquarium, we have a sonar sound playing. So if I stand here, I can hear the music coming from the left and the sonar coming from the right. If I move the mouse and rotate the camera, now I'm getting the sonar sound from the left and the music from the right. We can also check how the attenuation curves work. We also have some spread in place based on height. As we get away from the TV, we can now hear the music volume decreasing. We wanted to use the Wwise spatial audio features, specifically those related to reverb and occlusion. So we started by creating one auxiliary bus for each different room in our diverse board. For spatial audio purposes, these auxiliary buses need specific settings. The game-defined auxiliary sense needs to be enabled, then some room verb effect in place, and a specific configuration in the positioning tab. All of this can be quickly set up by using the Wwise default preset called Room Auxiliary Bus. Selecting this preset for your auxiliary basses will automatically set all the configuration that is needed for spatial audio volumes. Additionally, for every object that we want to be affected by the reverb, we need to override the game-defined auxiliary sense and check the Use game-defined aux sense option. For obstruction and occlusion, we need to perform two more steps. First, in project settings, we need to make sure our obstruction and occlusion curves are enabled both for volume and low-pass filter, and adjust them to your needs. Then we also need to select every object that we want to be affected by occlusion and obstruction, and in the Positioning tab, we need to enable the diffraction and transmission option. So this covers all the basic settings in Wwise. Now we are in Unreal Engine, and I have selected all our AkSpatialAudioVolumes volumes for each of our rooms in the diverse port. If we select one of these, for example, the dining room, we can see that we have different components. One of those is the late reverb. If we select this component within the spatial audio volume, it will show that section, and here you can pick the specific auxiliary bass that you created in Wwise for this specific room. For occlusion and obstruction, we can go into the room component, and there is one parameter that is called transmission loss that you can modify to set the amount of transmission that you want for each specific room. If you select one, this will just simulate very thick walls, and you will not hear any sound coming from neighbor rooms.
Okay, so here we have the AK acoustic portals. Basically, for the acoustic portals, they are used to transition from one AkSpatialAudioVolume volume to another. They also help transfer transmission between the AkSpatialAudioVolume volumes, affecting things like occlusion, and they also act as a transition between reverb zones so that the player can experience that transition as well. The important thing to know when setting these portals up about these portals is that they need to be set up precisely at the edge of both AkSpatialAudioVolume volumes. If even one of them is off, the box will turn red. So you just want to make sure that they are appropriately placed. Alright, so here we are in the Ocean Divers port level. As you can see on the profiler, we have our portals and our AkSpatialAudioVolume volumes set up to identify the different sonic environments that we're in. I'm transitioning into the dining room, which has a whole different audio space, which is also different from the bathroom that it houses. So for the credits video itself, essentially we just made our own. we took our final version of the credits video, and then we placed it into a media texture and created a playlist for it. So this playlist holds the credits video, and it's only really supposed to play once, so we didn't opt for looping. And that texture gives us this material, and now we have the material able to be placed on whatever object that we want. So for the credits level, we just had the same as the main menu. We had a user interface that basically played whatever video that we wanted to play, but spread out to the whole screen. Movies using this way doesn't really play music, so we had to literally chop the audio to play it as a 2D sound to play at the same exact time as the movie being played. And just in case, we had to rewind it, just in case anyone might have like skipped it. So this is just our follow through. And then once the movie ends, we have to have it on a delay, but it opens the level. So how we decided to implement our audio settings was through Wwise primarily. We wanted to use RTPC values such as the master volume control, music, sound effects UI, dialogue, and also the ambience in order to set up those RTPCs into our audio buses, whether it's master all the way down the line, so that in the UI we can tell the master volume control, for example, RTPC, to go down based on the slider that we give it. The slider is going to be between 0 and 100, so we use those values to tell how loud the audio should be.
For the game audio settings, we have created this basic menu where we have a volume slider and a mute checkbox for each one of the audio categories that we have in the game: master, music, ambience, sound effects, dialogue, and UI. We are going to showcase just the master as an example. For the slider, we used the event called onValueChanged, and for that event, we are stating that if the master volume is unmuted, then we are setting the RTPC value to the value of the slider. If the master volume is muted, then we are just storing the master slide value into the master variable. For the mute checkbox, we are doing something similar. We used an event that is called onCheckStateChanged, and for that we are saying if the master volume is checked, is muted, then we are setting the RTPC value to 0. And if the master volume is not muted, then we are changing the RTPC value to whatever value is stored in the master variable. Okay, now we are in the diverse board and we are hearing the sound, the music. We have sound effects for the footsteps, the ambiances, and I'm going to open the audio settings. Here we have the menu I showed you before with all the audio categories. I will mute the master volume, and you can see on the Wwise profiler that the master volume control RTPC is turned to 0 as expected. If now I move the slider, I'm changing the slider value, the RTPC value is not changing in Wwise, but the slider value is being stored so that now when I uncheck the mute box, the RTPC is picking up that stored value. And if I now move the slider around, I do hear and see the RTPC changing in the profiler. Same happens for the ambience volume control I can mute it, the RTPC value is set to 0. You can also modify the volume, and the same happens with every volume control. Okay, and that's everything that we wanted to showcase from our game. We hope you found it helpful. Thanks for watching.